Okay, so I'm going to go through an example here of using the p-value, figuring out p-value, because this is one of the areas in statistics, one that tends to pose one of the biggest problems is what is a p-value? How do we figure it out? This is one of the examples from the practice sheets. It says use both classical and p-value methods, but in this video I'm going to focus on the p-value method. So let's remember what the purpose of p-value is. The p-value tells us the probability, assuming that the null hypothesis is true. What is the probability of getting the whatever value that we get? Or something more extreme. More extreme can be higher if it's a right tail test, lower if it's a left tail test, or higher or lower if it's a two tail test. So let's go. I'm going to run through this example here. 10 years ago, the mean acreage of farms in a certain region was 65 acres. The standard deviation of this population was 9 acres. Okay, and a recent study consisting of 22 farms showed a mean of 60.5 acres per farm. Test the claim at alpha equals 0.10, that the average has not changed. So what does this tell us? Has not changed. It doesn't say that it's larger or smaller. It says has not changed. So I'm going to write this as a two-tailed test. So I'm going to say that, all right, it was 65, and I'm going to say that, show that it has, or try to show that it has changed somehow. Okay, so when I figure the p-value, the way I'm going to do this is I first have to calculate the z-score. So the p-value basically is saying this. Let's assume that 65 acres is the true population mean. What is the probability of getting a value of 60.5 acres or more extreme? So in other words, 60.5 acres is lower than 65, and so getting a lower value or an equivalent higher value. So the first thing you need to do here is figure out the test value of 60.5. Now, it says the standard deviation of the population, so that tells us that we are looking for a z-score here. And so I need to figure out what that z-score is. So I'm going to say 60.5 minus 65. That's our null value for the mean, over the standard deviation, or the standard error, right? So we have a standard deviation of the population was 9, and of course we have to divide this by the square root of n, which in this case 22, and I need to figure out what this z-score is. Okay, so we figure that out, and it comes out to negative 2.34. Okay, so let's think about what that means in terms of the p-value. So if we take a normal distribution and the hypothesized mean of that distribution is 65, which would result in a z-score of 0, because 0 is the mean. Now, what we actually had is 60.5, and we found that that has a z-score, again, taking into account this is a sample of 22, of negative 2.34. Now, because it's a two-tailed test, I have to look at both sides. I need to figure out what is the probability of getting a result of more extreme than 60.5 if 65 is the true population mean. So because it's a two-tailed test, I have to focus on not just 2.34, but I really have to focus on plus or minus 2.34. So I'm going to have to go 2.34 in this direction. And since that's the opposite side of the mean, well, this is a difference of 4.5 between 60.5 and 65.5. So that's going to be 69.5. But the point is, I don't really need the 69.5. The point is, I need to figure out the probability of getting a value at least this extreme. So at least this extreme could be on this side, or it could be on this side. And so my p-value is the sum of these two areas. And when I figure out what that sum is, I figure, okay, assuming that this is our population mean right here, the 65, what is the probability that I will get a sample mean less than 60.5, or because it's a two-tailed test, greater than 69.5? So what I need to do is I need to use the table 2, the z-score table, to find this area. So if I look in the z-score table, when I look it up in the z-table, I look at the area, and because the z-table gives me areas to the left, I'm going to look up this area, and it's going to come out to 0.0096. So 0.0096 is this area. Now, because it's a two-tailed test, and this is the thing, when we take a confidence interval, what do we need to do? Well, if I want 5%, I need to take that 5% and split it between the tails and divide it, so I'm finding 2.5%. Now we're going the opposite direction. We are finding an area. So 0.0096 is just the left tail area. So the actual p-value is going to be 2 times 0.0096, and that's going to result in 0.0193. I'm rounding up, so it's not going to be exactly double, but 0.0193, and that is our answer. That is our p-value. So what are we saying here? We're saying that that's not our final. We still have to make our conclusion, right? But what we're saying here is that, okay, if the population mean, if our null hypothesis is true, and our population mean really is 65, the probability of us getting a value as extreme as we got is less than 2%. Pretty low. Now, how low? Now, what was our criteria? Lower than what? Well, 0.10. So I'm going to say that our alpha level of 0.10 means that for us to reject our null hypothesis, for us to say that no, this value is too extreme, I need to have a 0.1 probability or less of incorrectly rejecting the null hypothesis, because that's what a type 1 error is. Because I got a p-value of 0.0193, my probability of, if I reject this null hypothesis, my probability of a type 1 error is less than 0.10. So, probability of type 1 error, so I'm going to say, okay, well, 0.0193, that is less than alpha. Therefore, in conclusion, we reject H0. And we say that, there's not enough room for me to write it here, but we say that we do have enough evidence to show that the acreage is different than 65 because the value we got is so much lower that it produces a p-value of only 0.0193. And that's what p-value is. P-value is a probability, and it's the probability of getting a value such as we get without assuming the null hypothesis is true. Okay, I'm going to do one more example, but I think I'm going to save that for another video. We're already up to about 11 minutes here. So I will do one more example on this page in a separate video.